So we're going to do inequalities that have that are less. When you see the inequality that's a less than sign, you're going to have what's called an and. And so we're going to break this into two separate inequalities and solve them. So I have 8 less than 3 minus 7. That's my first one. And then my second one is going to be the 3y minus 7 less than or equal to 23. So I'm going to solve both of these and then graph those answers. So if I solve this one, I have plus 7, 15, less than 3y, divide by 3. I get y is less than or greater than 5. And I'm going to actually move that around, flip the sign to make it so I can graph them much easier. And I'll do my blue one. I'm going to add 7 to both sides. That's 30. So 3y is less than or equal to 30. Divide by 3. Divide by 3. Y is less than or equal to 10. So now if I go on my number line and graph each one. So let's graph the red one. I'm going to start at 5. And I have an open circle. And I'm going to, let's do this. My fault. Let's erase this, make this a little nicer here. I'm going to start at 5 right here, open circle, and I'm going to move it towards the right, or greater than. And then if I do the blue one, it starts at 10, but I have a closed-in circle, and it goes in towards the red. So basically, what I'm saying is that because they intersect each other, my graph is really between these two colored in. All right, let's look at this next one. See, there's less than sign, so we're going to have a compound. So the graph is going to go towards each other. So I'm going to do my two equations, 4x plus 8. And I'm going to go ahead and solve that one. Minus 8, negative 20, divide by 4, x greater than or negative 5. But I'm going to flip it around so it's easier to graph. And then I'm going to do my second equation, 4x plus 8 less than or equal to 32 minus the 8. 4x is less than 20. What is that going to be? 624. And then divide by 4. X is going to be less than or equal to 6. Once again, I'm going to go on my graph. And my red one, I'm going to start at negative 5. It's a filled-in circle, and I'm coloring it towards. And if I go in the blue, I'm going to have a 6 filled-in circle, and it's going. Notice how they go towards each other, and so our graph ends up being an intersection or going towards each other. The other type of compound inequality we have is with an or, and that's when we have the greater than sign. The greater than sign, or the word or. In this case, we have the word or. So I have two equations, so I'm going to solve them first. K plus 6 less than negative 4. 5 minus the 6 minus the 6, k is going to be less than negative 10. And I'm going to solve my other equation, 3k greater than 14. When I divide by 3, k is greater than, and I'm going to go ahead and change this so I know where graphs on a fraction is going to go in 4 times 4 and 1, 2/3. So now if I go on my graph, my red graph, I'm going to go to a negative 10, which is somewhere here, and it's an open circle, but the graph's going to go to the left because it's going less. If I go to the 4 and 2/3, which is somewhere between 4 and 5, it's going to be a closed-in circle, and it's going to the right. So our or graphs go in opposite directions. And so they go in opposite directions, and there's the answer. So let's solve another question with the or. We have a g minus 6 greater than negative 11. If I add 6 to both sides, g is greater than negative 5. And if I solve my other equation, 2g plus 4 and 15, so minus 4, 2g is less than minus 20. Divide by 2, g is less than negative 10. So now I'm going to go on my graph. So this is the red one. I'm going to go to negative 5. And actually, I have to notice that I have a negative 5 is actually smaller. Negative 5, open circle, and it goes to the right. Blue one is a negative 10, open circle, and it goes to the left. So the arrows follow the same way as the inequalities, as long as the letter is on to the left. And once again, we have graphs that are going outward.